So Winter's formula is a formula designed to check if the PCO2 compensation for an acid-base disorder is appropriate for the change in the bicarb. So the formula is stated as expected PCO2 is 1.5 times the bicarb level plus 8 plus or minus 2. Before we go into this equation, I want to show you one thing, and that is that the acid-base status in our body is always in balance. So on one side of the equation there is bicarb plus hydrogen, which is in a state of irreversible reaction to carbonic acid, and it's also reversible to carbon dioxide plus water. So this equation is what governs the acid-base status in our body. So whenever there is an excess on one side, the equation, because it's in an equilibrium, it shifts to the other side and produces more of the others. For example, if there is an increase in carbon dioxide, the equation shifts to the right and causes more of carbon dioxide. If there is more of carbon dioxide on the equation, it can shift also to the opposite side to produce more bicarbonate. So this creates a system of compensation in which when one of the constituents of this equation is increased, it's compensated. So when the bicarb increases, we are in a state of metabolic alkalosis. So the equation shifts toward the right, it produces more carbon dioxide. So that this acidosis, which is created by the equation shifting to the right, balances the bicarb level, and the acid-base disorder tends to come to normal. So what we are looking through this equation, which is called the Winter's equation, is to see if this increase in carbon dioxide is for the purpose of compensation of metabolic acidosis or alkalosis, or is it an independent cause, factor other than this equation, in which the carbon dioxide level increases, and we have sort of a mixed acid-base disorder where we have metabolic alkalosis plus respiratory acidosis. So in order to see if the level of carbon dioxide that we see is a true compensatory increase in carbon dioxide, we use the Winter's formula, which states that the expected PCO2 is 1.5 times the bicarb plus 8 plus or minus 2. So to see this, we will take one example. So the Winter's equation states that the expected PCO2 is 1.5 times the compensatory PCO2 is 1.5 times the bicarbonate plus 8 plus or minus 2. So here we have the normal values. For our purpose, we will take the normal value of the pH, also X range, to be 7.35, bicarb level to be 25, and PCO2 to be 40. So based on this equation, let's take one example where there is a pH of 7.25, which is acidic, which is mainly driven by bicarb, because a low bicarbonate level is a metabolic acidosis. So let's take this one to be 15, and then because there is an acidosis, metabolic acidosis, if we recall the equation that I showed you before, which is bicarb plus hydrogen is in a state of equilibrium, changing into carbonic acid, and is in a state of equilibrium to water plus carbon dioxide. So if the bicarb level is low, as in this case, then we would expect the equation to shift towards this, so that decreasing the level of PCO2 in the system. So an increase in PCO2 causes a state of sort of respiratory alkalosis, and this compensates the metabolic acidosis that's created. So this is the equation that governs all acid-base disorders. So when one side of the equation decreases or increases, it affects the other side, and this equilibrium, and the shifting of the equilibrium towards the left or towards the right, keeps the balance of acid-base disorder in our body. So if you have a bicarb of 15, which is a decreased value, you are in a state of metabolic acidosis, so the equation shifts towards the left. So we would expect a lower PCO2. So normal PCO2 is just 40. Let's assume here we have 20. So according to the Winter's equation, the estimated PCO2 is 1.5 times the bicarb is 15 plus 8 plus or minus 2. So 1 times 15 is 15.5 times 7.5. So we'll have like 22.5 plus 8 plus or minus 2, which is 30.5 plus or minus 2. So we would expect it to be between 28.5 up to 32.5, because it says 30.5 plus or minus 2. So based on this, if there is metabolic acidosis with bicarb of 15, we would expect the compensation, which is the expected PCO2 level. We are going to write EPCO2 level should range between 28.5 and 32.5. So here what we have is a value of 20, which doesn't lie in this range. So in this case, we have a combined disorder. By combined, we mean one, we have got metabolic acidosis defined by the bicarb level, which is less than its normal value of 25. And secondly, we have also respiratory alkalosis. Okay, so this is just these values are just set for an example for our exercise purpose. In reality, I don't think we will have a pH of 7.25 on this case, because if it is a mixed disorder like this with a bicarb of 15 and PCO of 20, because this is respiratory acidosis and this is metabolic acidosis and this is respiratory alkalosis, you would find if a pH value which is closer to the normal, on less than the normal, but closer to the normal, like 7.32 or something like that. So just to summarize what we have said today, the Winter's formula is an equation or a formula that's used to check if the PCO2 compensation, the expected PCO2 compensation, and it shows you whether the PCO2 that you have from the laboratory investigations is appropriate for an appropriate compensation for the acid-base disorders that we have in hand. The equation is expected PCO2 is 1.5 times the bicarb plus 8 plus or minus 2. So we would expect the normal